Okay, we're going to work a couple of problems in sinusoidal steady state. Let's begin with this one right here. So I have a current source that's going to be sinusoidal in nature, a resistor, capacitor, and let's put a resistor inductor over here. Give these some values: 48 millihenry, 80 ohm. This is 240 ohm, 2.5 microfarad. And this is our I sub G, where I sub G is 200 cosine 5000 T milliamps. All right. Okay. Let's see, what are we after? We're after the voltage V0 across the 240 ohm resistor there. Okay, so let's see, if this were not time varying and this were a steady current source, how would you approach this? Well, here's what I think about. This looks like a current divider to me. The current coming here is going to be split, and some current's going to go down that way and some current's going to go down that way. If I knew what the current was going down this branch here through the 240, I could easily figure out V0 because it's just going to be that current there. Okay, well, if that's the way you would do it in the time domain for a non-sinusoidal source, then that's the way you would do it in the frequency domain for a sinusoidal source. But one of the first things you have to do is you have to transform from the time domain into the frequency domain. So let's do that first. The circuit itself looks the same. The components have different values, though. All right, so the 80 ohms resistors stay the same. This is now phasor V0, and this is going to be, now that's in milliamps, so that's the same thing as 0.2 cosine 5000 T in amps, and let's keep it in amps. So this is going to be 0.2 angle 0 degrees. Okay, and that's in amps. So this is 0.2. Okay, now we still got these. This is going to be J omega L, so it's going to be J times 5000 times 0.048, and according to my calculations, that's 240. So this is J 240 ohms. This is going to be minus J over omega C. C is 2.5 micro times 5000. Take the reciprocal of that. According to my calculation, that is minus J 80 ohms there. Okay, so let's see, what are we after? We want to know the current going through that branch. Let's just call that phasor I current. That would just be I up here. And using divider equations, I know that phasor I is going to be, let's see, this over here, 80 plus J 240 divided by this, the total thing, so it's going to be 80 plus J 240 plus 240 minus J 80. All right, multiplied by 0.2 angle 0 degrees. So this is just the divider equation. It is this resistance over here, this impedance over here, divided by the sum of both of those impedances multiplied by the original current that's being divided. So, there's your answer, but we need to simplify that. And one of the first things that we need to do is we need to take this, convert it into polar, take this, simplify it, add those two parts together. Let's do that part first. So we got 80 plus J 240 on top. Now we'll take the 80, add the 240, 8, 9, 12, 320 plus J 160 All right, multiply that times 0.2, angle 0 degrees. Now we need to convert these, and according to my notes, this is 253, angle 71.6 degrees divided by 358, angle 26.6 degrees, 0.2, angle 0 degrees. Now do the division, so 253 divided by 358 is 0.14, and the angle is going to be the top minus the bottom, so that's 45 degrees. According to my notes, I already did the multiplication on top and then the division. All right, so this is the final answer right there. Okay, let me double check that with my calculator here. 253 times 253 times 0.2 divided by 358. Yep, okay. All right, so there is our phasor I here. Then V naught is just equal to, well, let's see, V naught is going to be I times Z, which is 240 ohms. So it's going to be this I, 0.14, angle 45 degrees, times this one right here, which is just really 240, angle 0 degrees. And that turns out to be 33.6, angle 45 degrees. That's our phasor V naught. But we need to convert that back into time domain, so that's V naught equals 33.6 times the cosine of, what was our omega? There it is, 5,000 T plus 45 degrees volts. And there's our final answer in the time domain. Okay, so we're done with that problem right there. Let's go ahead and do a different type of problem. We did a current divider here. Let's do, I got a mesh current problem here. Let's do that one. In order to save some time, I already converted this one into frequency domain. All right, let's see, our I sub x is that current right there. All right. So here's what I want to find in this one. I want to find the voltage, let's call that V1 across this branch up here. I want to find V2, which is across that branch right there, and then I want to find V3, which is across that branch right there. I also want to find, I want to find all the currents here, and I'm using mesh current methods, so let's call this one I1, we'll call this one over here I2, so I want to find I1 and I2, but in the process I also have to find I sub x. Okay, and let's keep the convention that, you know, positives are drops and negatives are rises. So positive drop, this is what the textbook uses, and negatives are rises. And makes things easier when you're doing mesh current, because pretty much everything's going to be a drop except for the sources. Okay, well, let's look at the left mesh over here. And let's see, what have I got? I've got 1 plus J2 times I1. That's actually what V1 is. Plus 12 minus J16 times I1 minus I2. Then we're going to have a rise across this, which is going to be minus 150, angle 0 degrees, and that's 0, like that. Okay, before we go any farther, this is for our left loop. Let's simplify this. I've got I1 plus J2 I1 plus, now I'm going to have to multiply through this, 12I1 minus 12I2 minus J16I1 plus J16I2, and we can go ahead and put this 150 on the other side. That's 150 angle 0, but we don't have to worry about the angle 0 at this point anyway. Okay, well, I've got I1 and I2 stuff, so let's put it all together. I1, I'm going to have 1 plus, there's a 12. I'm trying to find all the real terms first. That's it. And then I'm going to have a plus J2 and minus J16. All right, plus I2. Now I'm going to have just that term and that term, so I'm going to have a minus 12 plus J16, and that's equal to the 150. All right, I can simplify this a little bit more. I1 is going to be 13 minus J14 plus I2 is minus 12 plus J16, and that's still equal to 150 here. All right, so that equation right there is, we've taken it about as far as we can. Let's go ahead and do the right loop now. And I'm going to have 1 plus J3 times I2. And now I'm going to be going through this, so I'm going to have a plus 39I sub x plus, I'm going to have minus 12 plus J16 because I'm going in this direction times I'm sorry, that's plus and that's minus, times I2 minus I1. Okay, and that's equal to 0. Yeah, I think I straightened it out there. All right, we're also going to have another equation here, that because we're going to have this I sub x. You know what I sub x is. I sub x is going to be I1 minus I2, like that. Okay, but we can start simplifying this, and I'll go ahead and plug this in as we go through it. So this is going to be I2 plus J3I2 plus 39I1 minus I2 plus, it's going to be 12I2 minus 12I1 minus J16I2 plus J16I1, and that's equal to 0. Okay, I can simplify this a little more. Let's go ahead and do that. Let's put the I1 up front the way we did here, and that's going to be 1, and I've got 39 of them there, so I'm going to have, 39, that's the first one, minus 12 plus J16 plus I2, and there's, I'm going to have that one, and I'm going to have plus J3 minus 39 plus 12 minus J16, and that's equal to 0. All right, I can simplify that a little more. Now 7 is 27 plus J16 plus I2, 39, 20, oh, okay. That's hard math, can't do that. But I think that's negative 26 minus J13, and that's equal to 0. Okay, so we have two equations, two unknowns now. Here's our equation 1, here's our equation 2. And we need to solve this. All right, well, how do you do that? How do you do this with your calculator? Well, again, if your calculator can do complex numbers, then maybe it can do complex simultaneous equations. That's entirely possible for it to do that. If you don't have that calculator, or you don't know how to use your calculator, then we're going to have to do it by hand. It's not that difficult, but like I said, it is tedious. Let's go ahead and go through that process, though. Let's take this one and solve for I1 in terms of I2, and then take that, plug it in up here, and then solve for solve for I2 out of that. Okay, so let's go ahead and do that. Well, yeah, let's do that. So I'm going to start with this equation right here, and I'm going to rewrite it. I'm going to say that this is I1 times 27 plus J16 is equal to, I'm just going to put this on the other side, and it becomes I2 times, you notice everything's got negative signs here, so I'm just going to say 26 plus J13, like that. Okay, then I1 is going to be I2 times 26 plus J13 divided by 27 plus J16. Okay, let's convert each of these into polar, and according to my notes, this is 29.07 angle 26.57 degrees divided by 31.38 angle 30.65 degrees. You should double check everything I do here. And this turns out to be I2. You do the division, and that's going to be a number less than 1.926. And the angle is going to be top minus the bottom, so it's going to be negative 4.08 degrees, like that. Okay, that is I1 in terms of I2. Okay, now it is expressed, we have this now expressed in in polar coordinates. I don't know if we're going to need it in rectangular coordinates, but I've already done the conversion here. So it's 0.924 minus J 0.066. Okay, and we may need that in either form. I don't quite know yet. All right, let's take this in that form and go back up here and plug it in right here. So this is going to be now equal to 150, and I'm going to take my I1 here and plug it in to that. Okay, so this is going to be I2 times 0.926 angle negative 4.08 degrees multiplied by 13 minus J14. Just double checking here. Yep, that's my I1, 13 minus J14, plus I2 times negative 12 plus J16. And I2 negative 12 plus J16, and that's equal to 150. I just put 150 on the left here. Okay, let's go ahead and multiply through, see if we can get this I2. Now, in order to do this multiplication here, I've got to convert the 13J, or negative J14, into polar. So I'm just going to rewrite the 0.926 angle negative 4.08 degrees. Now multiply this, convert this rectangular into polar, and it becomes 19.10 angle negative 47.12 degrees, plus I2, and we'll just leave it the way it is, minus 12 plus J16. We'll probably need to convert that later. No, we probably won't, because once we do this multiplication here on the left, we're going to convert that into rectangular so that we can do the addition. Okay, so I2, now it's time to do the multiplication, and when we do that multiplication, 17.687 angle, and you add, because we're multiplying, you just add these, and that's going to be 51.2 degrees, close enough. Plus I2 minus 12 plus J16. Okay, now in order for us to do this, we're going to have to convert this into rectangular. We might as well do that at this step. I2 times 11.08 minus J13.784 plus I2 times minus 12 plus J16. All right, we're ready to factor out the I2, and we just combine the real and the imaginary parts. So 11.08 minus 12, that's going to be 0.92. And then this and the J's are going to combine to make J 2.216. All right, so I2, converting this into polar, 2.4 angle 112.5 degrees, like that. Okay, and that's, remember, equal to 150 over here. So we're ready to find I2. That's going to be 150 angle 0 degrees divided by 2.4 angle 112.5 degrees. And that's going to be 150 divided by 2.4, and that looks like it's 62.5. And 0 minus 112.5 degrees. Okay, if I need to convert that into rectangular, I don't know that I'm going to need it, but I'm going to go ahead and do that. 20 minus 24 minus J 58 amps. All right, so that's I2, phasor I2, in its two different forms. So that was one of the things that we needed. So it's part of our solution is there. Okay, then we need to go back to our I1 up here. Now that we have I2, let's go back to I1 up here and plug that in. So I1, which is equal to I2 times 0.926 angle negative 4.08. That's what that is, just rewriting that down here. That's now going to equal to this right here, 62.5 angle negative 112.5 degrees multiplied by 0.926 angle negative 4.08 degrees. And now multiply the amplitudes, add the angles, 57.875, angle negative 116.58. I'm just using some arbitrary number of decimal places here. So there's our I1, and we can convert that into rectangular if we wanted to. Negative 26 minus j 52, rounding things. There's our I1. Okay, so we got I1 and we've got I2 at this stage. So I need, I'm going to rewrite those. My I1 was negative 26 minus j 52 amps. My I2, negative 24 minus j 58, so negative 24 minus j 58 amps. And then my I sub x, remember what I sub x was. Don't think I have it on this sheet of paper. Here it is. It's I1 minus I2. So I1 minus I2 is going to be this one minus that. So that's going to be 26 minus a negative 24. So 26 plus 24, that's going to be minus 2. And then it's going to be negative 52 plus 58. So that's going to be positive J6 amps. So we got our I1, I2, and I sub x. All right, great. Now we need the voltages, and if you go back here, the voltage across that, and since we know that that's going to be I1 going through there, the voltage is going to be V equals I times this total impedance here, so 1 plus J2. So V1, phasor V1 is going to be 1 plus J2 times I1. And then let's leave some room. V2 is right here. This is going to be I sub x times 12 minus J16. So 12 minus J16 times I sub x. And then V3 is going to be, that's right here. So this is I2 going through there, so it's going to be 1 plus J3 times I2. So 1 plus J3 times I2, like that. Okay, well, we know what our I1, I2, and I3 are here. We need to do the multiplication and figure out the answers. I will leave it up to you to go through those steps. You end up with 78 minus J104 volts. You end up with 72 plus J104 volts, and 150 minus J130 volts, like that. Okay? Now you can check that by summing around each one of these. So on the left loop, negative 150 plus V1 plus V2 has to equal 0. So in other words, V1 plus V2 have to equal that 150. So let's see, V1 plus V2, yeah, look at that, 8, 10, 14, 15, yep, that's the 150. And yeah, that's going to be plus negative 104 plus 104. Is that, oh, yeah. Oh, that doesn't seem right, does it? Oh, wait a minute, that's V2 has to be 150. Okay, so that's it. I'm not letting it equal this. I just had that wrong in my head. This 2 should equal 150 angle 0, and it does, 150 angle 0. Okay, you can do the same sort of thing for this loop over here. Make, V3 plus and this, and has to equal that. Okay, so you can do the some things up around that loop, and you'll see. So what is this? Negative V2 plus V3 plus 39 I sub x has to equal 0. So V3 plus 39 I sub x has to equal V2 there. You could also sum up around the outer loop and make sure that it's 0. That's just a way to check your work to make sure that these are correct, and they are. All right. I'll leave it up to you to do those. That's probably enough for this one video. Practice these problems. You need to be able to do the complex algebra, do it fairly quickly, and come up with answers and understand what's going on. But the thing you need to keep in mind is pretty much everything you've learned throughout the whole semester up until this point, all of those various techniques we learned before spring break can now be applied as long as you convert into the frequency domain, do your manipulation and your analysis there, and then convert back to the time domain to get your final answer. For this particular problem, we started in the frequency domain. There was no need for us to convert back to the time domain, but in another problem you might have to do that. And it's trivial to be able to convert between those two things. Okay, so I'm going to leave that there. Practice the various techniques, mesh current, node voltage, source transformation works, superposition works. All of those things work as long as you're in the frequency domain. Okay, we'll stop here.